All right, Chapter 8, string operations. Now, these we covered these string operations to illustrate that the x86 architecture represents the complex instruction set computer, CISC, class of computers. So the string commands that we're going to see are complex instructions in that they do more than one atomic thing at a time. But you will see, don't be fooled into thinking these are similar to the functions that are available in C string, for example. They are not. They're a little more flexible than that. So let's read about them. There's not much to this chapter, so this one should go pretty quick. Okay. Also, I'll point out that we're going to be looking at 6 instructions total. There are many more additional x86 instructions available. They're just not covered in the book. But again, having learned this, your ability to scale and learn others, I fully expect you'll have no problem. So, a string. Here, I need to define some terms because a string in the x86 environment is a little bit broader definition than in a high-level language, C++ or C, for example, where a string is generally speaking, it is a string of characters. In x86, it is simply a contiguous collection of bytes, words, double words, or quad words in memory. It could hold characters, it could hold values, so we've got a little more flexibility there. Now, we've seen how we've allocated some of these contiguous collections of bytes, words, and double words when we were doing all assembly language. So things like allocating memory for a label, which is just an array of strings. We did that by saying something like, label 1, a series of bytes, and then we gave it the initial string. The results are, or whatever we want to say. We may have intentionally just said, okay, I want to allocate a double word of values and call it array D, and I just want 60 of these with a duplicate initialization of 0 or nothing. I could use a question mark if I wanted to. This is fine. So I've seen how this is done. But again, these string commands, I can use them for single bytes when I need to. I can use it for words or double words. I'm not constrained. Okay, so let's look at the string commands. What we're going to do is look at them real quickly, but then we're also going to go into them in more detail. So move string copies a string from one location to another. Typically, the string is going to get copied from the source to the destination. Okay? Compare string. Exactly what you think. It compares the contents of 2 strings, source and destination strings. Scan string searches a string for a particular value. The particular value, anytime I'm looking for a particular value or loading a particular value or storing it, the accumulator is going to be used a lot in this case. And the scan string uses it, store string, and load string. So the next one is store string. Stores a new value in some string position. So this is generally going to go from the accumulator to a destination. Load string does the opposite. It loads a value from the source string into the accumulator. Typically, you're going to see these two working together, where we load and then process somehow and then store when we're done. So we see this combination used frequently in the string commands. Okay, so before we go into a little bit more detail, let's cover some basic rules for the string commands. First, each instruction applies to the source, the destination string, or both. The elements, when I'm dealing with strings, since I'm dealing with strings that are bytes words or double words, the elements are processed one at a time, okay? And in Chapter 8, when we introduce these string commands, we are now going to be using automatic registers. So the destination index register and the source index register are the default locations for several of the operands in these, okay? Register indirect addressing is used to locate the individual string elements where it's ESI and EDI. By the way, this would be RSI or RDI in 64-bit mode, okay? All right, I've got some variants I need to tell you about. Since ESI and EDI are automatically used, operands are not necessary, but we still need to have a way to indicate size. So what we typically do is size must be specified as a prefix to the instruction. So I could say, instead of just move string, I could say move string byte, move string word, move string double word. Okay, where each of these suffixes indicate the size. There is a coding variation that you might see. It's really bad programming style. I'll mention it here. I'm not even going to write it because I don't even want you guys to get used to seeing it. But that is, somebody would use a string command, move S, and indicate operands just so that the machine will read the operands to determine what the size of the operation is. Really bad coding style. It infers or implies that you're using operands other than source and destination index, which you are not, even if you say otherwise. So the preference is to use one of these suffixes. All right, a little bit more on string commands. So we said that for the string commands, they're operating on an element in the source or the destination one at a time, but at the same time, it's getting ready. So if I am moving from the source to the destination, after I've done the move, guess what? I'm going to move my pointers so that they're ready for the next move. Okay, so they get ready to operate on the next element. This kind of gives you some insight as to why these are complex instructions. Okay, one other thing. We finally get to one of the flags, one of the status bits in E-flags, destination, or direction flag, sorry. I can choose which direction I'm going to traverse an array of elements. I can either go, and the wording that the book uses is forward direction, which means left to right. That really means low to high memory, or backward direction, okay? When I want to set forward direction or left to right, I use this instruction. CLD clears the direction flag, and this is to set left to right or forward direction. STD sets the direction flag, and that's for right to left or backward direction. Okay? All right, let's play with move string a bit. What we want to do is design a piece of code that will just do what move says it's going to do. It's going to copy from a source to a destination. So it's null terminated. That gives us some help because I don't need to know how long this is. But this does also imply that it is a string of characters. So what are the things that we need to do? Well, let's see. I know some basic things I will definitely have to do. I've got to establish a pointer Well, I'm trying. A pointer to the source and to the destination. What else do I need to do? I need to set the direction. Which way am I going? Am I going left to right in both of these or right to left? So in this case, we're going to clear the direction flag. So it's misleading to say we're going to set the direction. Set it in terms of indicating what the direction will be. In our case, let's say we're going to set left to right direction, which means we're going to use the clear direction command. All right, then I need to figure out how I'm going to get out of this loop. Well, it's a null terminated string, so one of the easiest things to do is let's compare the current. So let's see if source value is equal to null. Okay, if that's true, then we're done. If it's false, yeah, we're in. We're good. Okay, so we'll come back and annotate that in a second. But what if it's false? What if it's not null? Well, then I need to do a move. What do I need to do? Well, let's say we want to copy source to destination. Okay, then we want to I need to increment my source index. I'll just say increment. And increment destination index. This is where my string command will come in and do both of these things. Okay. And then finally, after I've incremented my destination index, then I'm ready to go back up and see if I've hit my termination condition. Okay, if I haven't, then I'm going to come down here when I'm done and say, oh, the only other thing I need to do is terminate, null terminate the destination. Okay, so there's my design. Let me show you this code real quick. We'll look at it in class, but this way we'll have a pretty good idea of what's in it. And then we'll call this one a video, and we'll pick up the rest of them on the next one. Okay, so here is the complete example. This one's in your textbook. So again, assume ahead that we're establishing a stack frame and doing all those good programming things to do up here. Then I'm going to pull my parameters only as I need them. I'm going to set left to right motion or traversal direction. I'm going to compare the current to null. If it's equal, I'm done. Otherwise, there's my string command. Move, copy 1 byte from source to destination, go back up here, and see if we're done. When we're done, I'm going to null terminate the destination, and then fall into whatever I fall in at the end. Okay? All right. We'll pick up the rest next time.